Okay, welcome back. In this video we're going to take the part 2 of the bone crusher assembly and work through the animation of the gear and the rack plate. So the first thing we're going to do is we're going to start putting together the rest of the bone crusher here. So I'm going to grab place components and we're going to work our way down through here. And the next part that I'm going to want is going to be the shaft for the gear and the handle. So I'm actually going to go ahead and grab that. And an important piece here is the positioning of this shaft and what side of the shaft goes where. So it's going to be important to actually get some real measurements off of this. So what I'm actually going to do is make sure that this file is saved. And I'm going to go ahead and really quickly lay this out on just a standard layout sheet so that I can actually create some dimensions and gain some more specific information off of the assembly and off of some parts here very quickly. So go ahead and lay this out and grab my annotation information. First I'm going to go ahead and center mark these two holes, because these two holes are not at the same position away from the outside edge. So I'm going to go ahead and do this and actually find that is 0.63. And I believe this one is 0.5. That's actually very important to know, because one of these goes in one area and one goes in the other. Now I'm actually going to find the center. And that's what I want to know. From the outside edge, which I want my shaft to be flush with, I need to know that this is the end that's going to be flush over on this side of the rack, and that out here is going to be the handle. And I really do like to do this in a few different ways, so that I can definitely make sure I know the orientation of my parts to my assembly. So I many times lay this out and then be able to just gain information in a very clear visual way from my layout. So I'm going to go back here to my assembly now, knowing that this is the top portion that needs to be inserted on this side. I'm just going to go ahead and do a little bit turn here and grab my constraint tools. And in fact, actually no, I'm not going to use constraint. I'm going to use my joint tools, because I'm going to want to drive this constraint later. So I'm going to then go ahead and grab my rotational constraint, and I'm going to grab the top face of that shaft, and then I'm going to come down here and I'm going to select what would be the top face of the particular hole here. And I can see that that joint constraint is getting itself set up, and I'm actually going to set this up in, nope, that would be the correct way to do that. So with that being set up in position, I'm going to go ahead and hit apply, and you can see now after I hit apply it is flush, and I'll have to flip that around. So I'm going to cancel out of that, and I just want to now move myself back around here. And I'm going to want to start working with this assembly from probably out here on the handle first. That way you can see some of the specific assembly constraints I'm going to use to get this to work. So I'm going to pull out some more parts here, and let's see. Yep, I'm going to definitely want the handle, so we'll go ahead and bring that in. And then I'm going to go ahead and bring in 2 pins that I'm going to use. And it looks like it's going to be part 10. And I'll go ahead and grab 2 of those right away. So now what I want to do is I want to go ahead and start constraining the handle here so that the handle is in relationship to this shaft. So I'm going to go ahead and set up that relationship between these two, just like that, and hit apply. And so that was center line of the shaft with center line of the handle. So it can still spin and still move back and forth, okay? So the next thing I'm going to do is I'm going to use another constraint, and it's just going to be another simple constraint, center axis. And I'm going to go ahead and put it center axis here of the shaft. And just to see the relationship, slides up and down. Shaft actually can still spin and turn, but this will slip right on out. In fact, I want to pull that out a little bit, because now what I want to do is I want to set up center axis of what's going to be the pinhole with the axis of the shaft hole, and hit apply. Now this should actually slide on in without any issue, and I'll go ahead and constrain that using a tangent constraint. So I'm going to constrain that face to this face, and actually let's flip it around that way so it's flush. Good. Hit apply and cancel. Now what's important to see, and I want to go ahead and turn this a little bit so you can actually see down inside here, and I'll push this up a little bit. is what we should be able to see is as I move this around, oh, still can't see that hole move. So I'm going to try and position this a little bit better so you can see down inside here, you can see this hole move. There we go. So my handle is actually driving the motion of that particular shaft. So now to make this work out a little bit easier for all of us, I'm going to go ahead and, well, let's spin this thing around in the right position here first. I want to go ahead and hide or turn off the visibility of this part 4.1. So we'll go ahead and turn that off. That way we can see what's going on inside here just a little more clearly. So I need to go ahead and now constrain. Move my handle out of the way too. I want to go ahead and constrain the gear in the same way where I grab my joint. Oh, I'm sorry, not joint constraint. Constraint, and just grab the center axis and select center axis. Okay, so those two are all set. Now what I want to do is set up the constraint for my pin into the necessary holes here. So we'll go ahead and spin this thing around until I can find the hole on this gear. Actually, let's turn my view is what I was trying to do here. Somewhere around here. Oh, there it is. Alright, so I can see where that's located. Alright, so spin this around so I can see it a little better. Okay. So I'll grab my constraint tool, center axis again, and center axis, here we go. Alright, so that's good, and hit apply, cancel. Now what I need to do is I got to get to see the hole down inside here. Probably should have constrained that pin to the shaft first. So what I'll do is I'll just find my gear and I'll quickly turn that visibility off. And then what I'm going to do is just rotate this around so I can see that a little better. Grab my constraint tool, grab the center axis of the pin, and then grab center axis of the hole, and now hit apply. Now I'm actually going to take and just pull this pin up a little bit so I can see it when I turn my gear back on. So now with the gear's visibility back on, I can again do that same type of tangent constraint. So it's going to be top face that's going to be tangent down here to this face of the gear. And then hit apply. Alright, so what should happen here is when I move that handle, I should be able to move that gear around. So bear with me as I flip this thing all over the place. There we go. So as I move the handle, it's going to move. Oh, wait a minute. I got a pin sticking out here. So I guess my tangent is upside down. So what I need to do is go back in here. I'm going to find that tangent relationship, and I need to edit that, and I'm going to change the location, just the solution here, and hit OK. So now as I spin it, yeah, now the pin's inside there. Okay, good. So now that's set up. So now what I'm going to do is I need to set up the motion. So as I spin, move the handle, which moves the constraining parts, that the rack will then move up and down. So I'm going to go ahead and turn and take a look at this and see how this is set up. And before getting into any type of deep positioning, I'm just going to eyeball position these gears into position here and slide back out so that I can start setting up my constraints. So I'll go ahead and grab my constraint tool, and this time I want to use motion, and I want to use a rotation translation motion, and I want to set it up so as this face turns, I want this face to move up or down. Alright, and I'm not going to deal with any type of rotational information here yet. I'm just going to work through here and see, does I move one? Yep, it moves. Now, as you can see, it's actually moving backwards. Alright, so that's not what I want to have happen. But I'm going to go back in here to this rotation translation, and we'll edit that. So I'm going to just change the solution. And now I can actually talk about getting set up with the circumference. So what I need to do is take the circumference of the gear, which is 1.5, and I'll turn my calculator on here, and I'll just go ahead and set this thing up. So 1.5 times 3.14 for pi, and hit enter. So I need 4.71 to be put in here for my distance. 4.71, good. So now what should happen is we should be moving at the proper setup and proper relationship here. So let's just take a look at this. Yep. So it looks like the gear teeth are moving properly, and this should work. Now what I can do is go ahead and just turn back on the arm. So let's go ahead and set that visibility back up and see nothing changed, nothing happened. So now the last thing to do here is we can drive some constraints. Alright, so to set up a constraint drive, the part that I actually used a joint on, and that would be this shaft, is what I'm going to find. So it's part 9.1 here, so I'm going to go ahead and grab that particular part, open that up, because it's that constraint, that rotational constraint, is what I'm going to right click on and then select the drive option here. Driving a constraint means that this constraint should be able to move given the certain parameters of motion. What it's saying here is that the start is being set up here at a minimum, and then there's an end or start here, the start and stop. So as I hit play, you can see it moves very slightly because it's only moving a few degrees. So I'm going to go ahead and increase the degrees of motion here, or the distance between the two, and then you can see that this will now move on its own given the drive constraints. So we'll just give this slightly larger movement so you can see that, and we'll take it back down so you can get to see some movements. That's driving a constraint. Right, so I hope that helps you get through this basic assembly here on the Bone Crusher assembly project.